Magnetic effect of electric current. Numbers and groups. Magnetic field due to current carrying by different types of conductors. Right and left hand thumb rule. Solenoid, electric motor. Magnetic field due to current carrying conductor. This is long straight copper wire connected to an electric current. Now place it parallel to and over compass needle. Plug the key in the circuit and observe the direction of deflection of the north pole of the needle. If the current flows from north to south, the north pole of the compass needle would move towards the east. Now reverse the connection of the battery. You will find that now the needle moves in opposite direction, that is, towards the west. It means that the direction of magnetic field produced by the electric current is also reversed. Magnetic field due to a current through a straight conductor. This is a copper wire connected vertically to circuit. This is cardboard and we place here compass and sprinkle some iron fillings. This is the rheostat to vary the current. Now fix current for 4 ampere with the help of rheostat and switch on. Now observe what happens if the current vary. We find that if the current is increased, the deflection also increases. It indicates that the magnitude of the magnetic field produced at a given point increases as the current through the wire increases. Now what happens if the distance between compass and copper conductor increases? As the distance increases, the deflection in the needle reduces. Thus, the magnetic field produced by a given current in the conductor decreases as the distance from it is increased. Right hand thumb rule. If you are holding a current carrying straight conductor in your right hand such that the thumb points towards the direction of current, then your wrapped fingers around the conductor represents direction of the field lines of the magnetic field. Magnetic field due to a current through a circular loop. When current carrying in a circular loop, the concentric circles representing the magnetic field around it would become larger and larger as we move away from the wire. By the time we reach at the center of the circular loop, the arcs of these big circles would appear as straight lines. It is only because of every section of the wire contributes to the magnetic field lines in the same direction within the loop. Therefore, if there is a circular coil having n number of turns, the field produced is n times as large as that produced by a single turn. This is because the current in each circular turn has the same direction and the field due to each turn then just adds up. Magnetic field due to a current in a solenoid. A coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. The pattern of the magnetic field lines around a current-carrying solenoid is as shown. The field lines inside the solenoid are in the form of parallel straight lines. This indicates that the field is uniform inside the solenoid. A strong magnetic field inside the solenoid can be used to magnetize magnetic materials like soft iron. The magnet so formed is called an electromagnet. Force on a current-carrying conductor in a magnetic field. French scientist André Marie Ampère from 1775 to 1836 suggested that the magnet must also exert an equal and opposite force on the current carrying conductor. This is an arrangement for showing force by magnet. This is a small aluminum rod connected with wires. This is a strong horseshoe magnet placed in such a way that the rod lies between the two poles with the magnetic field directed upwards. Now, pass a current through the aluminum rod. It is observed that the rod is displaced towards the left. Reverse the direction of current flowing through the rod and observe the direction of its displacement. It is now towards the right. Now, interchange the two poles of the magnet. Once again, the direction of force acting on the current carrying rod gets reversed. Fleming's left-hand rule. Stretch the thumb, forefinger, and middle finger of your left hand such that they are mutually perpendicular. If the first finger points in the direction of magnetic field and the second finger in the direction of current, then the thumb will point in the direction of motion or the force acting on the conductor. Electric motor. An electric motor is a rotating device that converts electrical energy to mechanical energy. Electric motor is used as an important component in electric fans, refrigerators, mixers, washing machines, computers, MP3 players, etc. Do you know how an electric motor works? This is an arrangement of electric motor. This is rectangular coil ABCD of insulated copper wire. The coil is placed between the two poles of a magnetic field. The ends of the coil are connected to the two halves P and Q of a split ring. The inner sides of these halves are insulated and attached to an axle. The external conducting edges of P and Q touch two conducting stationary brushes X and Y. That's all in this topic. Learning is fun.